students. Now today, as we are already practicing sums from R.S.Agarwal book, so today also we'll continue with the same chapter, that is chapter 5, Exponent and Power. And today again I have come up with 3 sums of exercise 5a. So as you see on the whiteboard, the first sum is sum number 2 of question number 17. So today also we'll do 3 sums. Now what is there in sum number 2 of question number 17? So we have 8 into 2 to the power n plus 2, and that would be equals to 32. So we have done this type of sums earlier also, but in that case the base were same. So I said at that moment also, the first thing in this type of sum where you have to find the value of n or x, you first have to see that whether the base are same or not. Okay, so in this case we see the base are not matching, isn't it? So we have to make the base similar. So 2 is a prime number, so 8 and 32 are composite numbers. So we'll try to change this 8 and 32 with a base of 2. Okay, so if you do the prime factorization of 8, so in place of 8 we can write 2 to the power 3. Okay, that is 3, 8, 2 4s, 2 2s, 2 1s, isn't it? So 8 is a combination of 3 2s, so it will be 2 to the power 3. Okay, now the next thing what we'll write this as intact. Now we'll also change this 32 and we'll try to make the base 2 only. So for that again we have to do the prime factorization, that is 2 16s, 2 18s, 2 4s, 2 2s and 2 1s. So how many 2s? 1 2 3 4 5. So in place of 32 we can write 2 to the power 5. Understood? Now you see that both the LHS and RHS are having the same base, isn't it? Now the first of all we'll try to solve the LHS. So that means, see, both the base are carrying the multiplication sign in between. So in multiplication what we do? We add the powers. Okay, we know this. That is a to the power n into a to the power m. So it would be n plus m, isn't it? So this is the property that we are using here. So we will put it inside the box. Okay, so that would be what? 2 to the power 3 plus n plus 2, and that would be equals to 2 to the power 5. Now we'll try to solve this. That is 2. We'll solve the constant part. That is 3 plus 2 is what? 5 plus n, and that would be equals to 2 to the power 5. Now when both the sides are carrying the same base and only singular form of base is present, so we will compare the power as we have done in the previous video, isn't it? So we will write comparing the power, isn't it? Comparing the power. So that power is what? 5 plus n, and that is equals to 5, isn't it? Now to get the value of m, what we have to do? We have to transpose this 5 towards right hand side. So it will look like what? N would be equals to 5 minus 5. So the value of n is what? 0. Okay, so this is a required solution of sum number 2 of question number 17, students. Now let's move on to sum number 3 of question number 17. So sum number 3 of question number 17, we have 6 to the power 2n plus 1. This is a division sign given. Division, that divided by 36 equals to 6 to the power 3. Now you see, in 2 cases the base is 6. So is there any way possible that we can turn this 36 with the base 6? Yes, it is possible, because we know that 36 is what? 6 into 6. Isn't it? That is, in place of 36 we can write 6 square. So in that way what will happen? We will make the base similar. So 2n plus 1 give division sign. So in place of 36 we can write 6 square, and that would be equals to 6 cube. Now once we have done this, so we can see that all the bases are similar now. Now we will first try to solve the LHS. So LHS is what? See, the base are same, but now this time there is a division sign. So what we do with the division sign? So a to the power n divided by a to the power m, that would be equals to what? We subtract the powers, isn't it? So this property will use it here. So this property will use it here. So that would be what? 6 2n minus 1, 2n plus 1 minus 2. And this would be equals to 6 to the power 3. Now we'll solve this too. So what will be the answer? 6 to the power 2n plus minus is minus. 2 minus 1 is 1. Which sign is greater? Minus, as because 2 is greater than 1. So 2 is carrying minus sign. So we'll put minus here. So that would be equal to 6 to the power 3. Now both the sides are carrying the same base. So we'll now compare the powers. So comparing the powers. So that is 2n minus 1. That will be equals to 3. So to get the value of n, the first thing that we have to do is we have to transpose minus 1 towards right hand side. So it will look like what? 2n is equals to 3 plus 1. So the next thing is what? 2n equals to 4. N would be equals to 4 by 2, and that will give you what? 2 as a answer. Okay, so now let's do the last sum of today's session. That is sum number 18. Now this is a very interesting sum, students. Now you see on the left hand side we have two different base. That is, one is 2 and one is 5, and they are carrying a power. They are having a power n minus 7. That is, 2 base is carrying n minus 7 as a power, and base 5 is having power as n minus 4. And on the right hand side they have given 1250. So now the challenge is to get the value of n with a different base. Now the first thing that we'll do, we will prime factorize this 1250. Okay, so 1250 will prime factorize it. So it is divisible by 2. So 2 6 are 12, 2 25 are fine. Now this is not divisible by 2. Now not divisible by 3 also, because 6 plus 2 is 8, 8 plus 5 is 13, 13 is not divisible by 3. So it will be divisible by 5. So 5 1s are 5, 5 2s are 10, 5 5s are 25, 5 25s are 5 5s are, and 5 1s are. So we'll write it down over here. So we'll write 2 to the power n minus 7 into 5 to the power n minus 4. That would be equals to what? 2 into how many 5s are there? 1 2 3 4. So we can write 5 to the power 4. Okay. Now if you compare LHS and RHS, you see that in LHS we have 2 as a base, RHS also we have 2 as a base. In LHS we have 5 as a base, so RHS also we have 5 as a base. So what we'll do is that we'll split this equation into two parts. That is, we will compare this base with base 2 with this base, and base 5 with this base. Okay, so how to write it down, you see. So now we'll compare this part with this one, and we'll compare this part with this one. Okay, so if we compare this 2 with this 2, okay, so what we will write? We will write 2n minus 7 would be equals to 2. Okay, similarly what we will write? 5n minus 4 is equals to 5 to the power 4. Okay, so let's do it then. So in this case, if we compare the power, comparing the power, so what will be the answer then? N minus 7 would be equals to, now this 2 is carrying 1 as a power. Fine, this 2 is having 1 as a power. So now how to find out the value of n? We have to transpose this minus 7 towards right hand side. So that would be equals to, n is equals to 1 plus 7. So the value of n is 8. Okay, for base 2. Now again for this also we will again compare the power. That is comparing the powers. So see, n minus 4 would be equals to 4. So if you have to get the value of n, we have to transpose this minus 4 towards right hand side. So value of n would be what? 4 plus 4. So n is equals to 8. So you see, in both the cases we are getting the same answer. So hence the value of n would be equals to 8. Okay students, so that's it for today's session. Thank you so much. God bless you all and stay blessed.